Okay, an unprepared student makes random guesses for the 10 true-false questions on a quiz. Find the probability that there is at least one correct answer. And express your answers. A percent rounded to 3 significant digits. Okay, so let's think about this. This is a 10-step process. You're going to answer number 1. It's going to be a guess. Then you're going to move on and answer number 2, and then number 3, and so on until you answer all 10 questions. So let's think about possible number of correct answers. Possible number of correct. Well, you could get all 10 questions wrong if you're very unlucky. You could get 1 right and 9 wrong. You could get 2 right and 8 wrong, and so on. 3, 4, 5 correct, 6 correct, 7, 8, 9, or you can get all 10 correct. Now, this problem contains an existential quantifier, at least one correct answer. So at least one means 1 or more. So at least 1 accounts for all of these possibilities. 1 correct, or 2 correct, or 3 correct, or 4 correct, and so on. Keyword there is or, which means we would have to, if we were to calculate this probability directly, we would have to apply the addition rule for probability and calculate the probability of 1 correct answer. And then add that to the probability of 2 correct answers, and then add that to the probability of 3 correct answers, and so on. A lot of work. So the event we're looking for, A equals at least 1 correct. Our event A consists of 10 individual mutually exclusive outcomes. So to calculate P of A directly, like I said, is a lot of work. But we have a rule for complements, and we know that the probability that A happens is always equal to 1 minus the probability that A does not happen. And in this case, there's only one way that A doesn't happen, and that's exactly 0. Exactly 0 correct answers. So none are correct. And that's a much easier thing to calculate because there's only one way that could happen. So each problem is true-false. So you have 2 options. It's like a coin flip, 50-50. You have a 50% chance of guessing correct. You have a 50% chance of guessing incorrect. Okay, so the probability of not A. Well, not A is none are correct, meaning the first question is wrong, and then the second question is wrong, and then the third question is wrong, and so on, and then the 10th question is wrong. Okay, so that's a sequence of 10 events. That's the multiplication rule. So the probability that the first question is wrong is 1 out of 2. Second question is wrong is also 1 out of 2. Third question, fourth question, fifth question, all the way up to the 10th question. Each of those 10 individual steps in the sequence has a probability of 1 over 2, or 0.5. So we can say the probability that not A happens, or the probability that A does not happen, is 1/2, or we could say 0.5 to the 10th power. All right, so we could bring that over here. And we'll come back to probability of A. So the probability of A is equal to 1 minus 0.5 to the power of 10. And this is a job for the calculator. So let's say 1 minus 0.5 raised to the 10th power. So if we were to calculate the probability of A directly, it's 10 separate problems, and they're not all that straightforward. But to calculate using the complements rule, it's just one step, because the complement of A can only happen in one way. All right, so give your answer as a percent, round it to 3 significant digits. Okay, so the calculator is saying, well, we want our answer as a percent, so let's times that by 100. Okay, so we had 0.999023437, or when we convert that to a percent, that was 99.9023437. And 3 significant digits, or in this case 3 decimal places, we'll cut it off right there. So it looks like our final answer is 99.902%.